In this video, we are going to talk about how to set up the chemical shift covariance analysis, or CHESCA. You can start CHESCA here in NMRFAM, then perturbation analysis, CHESCA-SPARKY. CHESCA relies on a library of different ligand bound or mutation, active or inactive states, and when necessary, the intermediate states. We recommend at least 5 states for each analysis. In our example, we have the APO and RP cyclic AMP as bound states as the inactive states, and cyclic AMP, 2'-methyl cyclic AMP, and the SP cyclic AMP as bound states as the active states. First, we will create a state list for the analysis and simply input the state name and select all the spectrum associated with this state. Remember to hold down Control key to select multiple spectrum, and repeat this for all the 5 states. After you create a state list, you will want to select an antagonist state and put it on top. We will be using the RP antagonist state as the reference state, so we select it and put it on top of the list. This reference state is later used in the SVD analysis, and you want it to be on top of the list before you start the job. Several parameters need to be set before you start the analysis. First is the n-dimension correction factor. As we mentioned for CHESPA, N15 has a lower gyromagnetic ratio, which leads to a larger chemical shift than the H dimension. I recommend 0.2 for this factor. Then is the correlation coefficient for the chemical shift correlation matrix and the agglomerative clustering. The cutoff 0.98 is a good place to start for both coefficients. The agglomerative clustering and singular value decomposition also requires a chemical shift frequency cutoff to exclude subtle chemical shift differences to minimize error. We use 5 Hz and Hz for the N and H dimensions. Additionally, there is an optional filter to eliminate errors derived from signals that are too close to each other. You can either use the user option to input the chemical shift difference by yourself. The default is set at 0.05 ppm, or you can use the average line width, but it requires you to integrate the peaks before you start. Here, for this example, we are just using the 0.05 ppm as the default here. Once the state list and the analysis parameters are configured, you can save them for later use. Once you are finished, click Run to start the job. The runtime for the chemical shift correlation matrix depends on your computer hardware. Meanwhile, the agglomerative clustering and SVD are submitted to an NMRFAM server and should be finished within seconds. Today we have set up and run a CHESCA in this video. In the next video, we are going to demonstrate how to visualize these results.